Good morning and good afternoon, everyone. Thank you for attending the webinar, How to Use Managed and Prioritized Workflows to Reduce the Cost of Review. I know that this is a topic that's near and dear to everyone's heart on how we could use advanced technology-assisted review to speed our reviews and to reduce the cost of them. We have a lot to cover now in the next hour, so we're going to dive right in. First, we're going to have panelist introductions. We're going to talk about what is a managed prioritized review and what is the technology underlying continuous multimodal learning. Get into the nuts and bolts of what we actually do in a CMML review, what some of the outcomes that we have and the return on investment and how much money it saves, how much time it saves. Talk a little bit about protocols and defensibility. I know that a lot of people are squeamish about diving into some of the technology-assisted review protocols, so we're going to try to dispel some of the myths here and talk about how easy it is to get these things rolling, and then we're going to leave plenty of time for questions. Now, we might not get to all of the questions at the end of the program, but keep your questions coming through the GoToWebinar interface, and we will collect them and we will answer them on the D4 website, or you can send your information to marketing@d4discovery.com. And so I'm going to roll now into the introductions, and Kaylin Johnson, I'd like to start with you.
Sounds good. Thanks, Chuck. So I'm Kaylin Johnson. I'm a Director of Delivery here at Special Counsel. I've been working with Special Counsel for about 5 years now, project management and that side of things. My experience is working with review teams and designing and implementing workflows for review teams, especially those using technology like predictive coding and machine learning. So that's what I'll be talking to today.
Kaylin, thanks. Charles Roberts, over to you.
I'm Charles Roberts. I'm a discovery engineer at D4. I focus on using machine learning and technology-assisted review. I work with Kaylin as my partner when we go into managed review, and I help our clients along the way and provide insight and guidance for the defensibility of the protocols when we use them.
Thanks, Charles. Dave Lewis.
Hi, I'm Dave Lewis. I'm Chief Data Scientist at Brainspace. Joined about a year and a half ago, but I've been doing text analytics since 1985, I guess. I'm here to talk about Brainspace's new continuous multimodal learning approach and how it can save review effort.
Dave, thanks. And I'm going to stay with you here for a minute. What is continuous multimodal learning, or CMML, and why is it for technology-assisted review? Why is it a better mousetrap?
So continuous multimodal learning is the result of our rethinking at Brainspace what the role of supervised machine learning is in investigations and litigation. And just in case anyone's not sure, so by supervised machine learning, I simply mean teaching a computer by example, what often gets called predictive coding in eDiscovery. So this is a responsive document, this is a non-responsive document, and that has been a very good fit with the sort of traditional batch-oriented coding of documents that people have always done in eDiscovery. But we really wanted to rethink this because not everything needs to be kind of a heavyweight batch-oriented approach, or not everything needs to sort of wait until you've done a lot of effort before you use machine learning. So we set forth the idea that, can we do machine learning with no extra effort? So that rather than going into the software and doing the machine learning part, you would just do what you would do with a tool anyway, which is to go out and look for the documents you're interested in. And the software should just be able to leverage that. So we completely redesigned our interface. We introduced very powerful sort of notebook tagging capabilities that make it very easy using any of our analytics tools to find documents on topics of interest and keep track of them. And then anytime you want, you can then use that data, use the documents you've already found to train a predictive model. So you don't have to wait to label a big batch. You don't have to label a control set, a random sample. You just do what you would do anyway, which is use a bunch of different text analytics tools to find interesting material, and then train a predictive model and use that to find more good stuff like that. That sounds really simple, but it's incredibly powerful combined with all the different tools, conceptual search, metadata search, looking at communication patterns, looking at sort of a clustering of the whole collection. All these things then feed back into predictive coding, into supervised machine learning, and then supervised machine learning feeds back into all of those. The idea is to make machine learning, supervised machine learning, an everyday part of the task of looking for information, not a kind of big, separate, heavyweight thing you do.
So I know, Dave, that a lot of your work over the years has been to be able to put zero extra effort into review, to actually reduce the review of non-responsive documents and increase the focus on just responsive documents. Is this a better mousetrap? Is this a way to just focus on the responsive documents and to find more of those and to reduce the effort in the information that's not as relevant to your case?
That's certainly one mode to use it. So people sometimes talk about various kinds of continuous active, there's a trademark term I won't use, but various kinds of continuous learning approaches. And essentially that's just what people in computer science call iterative relevance feedback, where you take the current predictive model and then you train on the top ranked documents. So our CMML interface has a very easy way to sort of blow through the top ranked documents, one-click tagging them as responsive or non-responsive so they can be used for training. But I do think it's important to realize there's a lot of other analytics tools, and iterative relevance feedback is very powerful, but there's also a lot of other tools which potentially are powerful too, based on you may know something about particular custodians or document types or date ranges or groups of documents. And Brainspace has analytics tools that let you leverage any of those kinds of domain knowledge you have to find responsive documents in addition to leveraging the predictive model.
So that's a great transition, Dave. Charles, I'm going to flip it over to you. How do we set up these projects? What do we do first, second, and third? And when Dave's talking about modes, maybe you can talk a little bit about the modes that we could use to find responsive documents and train the engine.
Yeah, first, once we've identified the documents that we're obligated to review to more than likely include in a production, we ingest that into Brainspace. At the Brainspace part, we can begin using some of the multimodal tools. One might be the communication analysis, and here, as soon as we get it ingested, we can have a look and see what the data looks like. And we may want to start with particular areas, particular times. The action of where things actually happen might only occur in a very narrow time point, within a month. And we can see those documents, we can see kind of the terms that are important there, and start making some judgments about what to look at first and start our review at, rather than just starting with custodian number one.
Right, so the screen that we're looking at here now, Charles, modes of review for keywords and date ranges. It looks like we've got month and year stacked up on the top, and keywords here in the middle and custodians down below. Is this interactive? Is this something that you could click into and actually look at documents and select them and review them and mark them?
Yeah, that's one of the really great things about this tool is you could click, maybe we see that Raptor is important, and that month where a lot of discussion happened, we can click on that, and that creates a search, that we can either open up some documents here in Brainspace or create that search and start review, batch it out to our reviewers in Relativity.
So let's look at another mode here. What are we looking at here on this slide with the big colored wheel?
Yeah, this is the concept cluster, and it's organized our documents, according to what the substance of those documents are. At the bottom, our review is about organizing documents, and that top level way we're trying to organize it is by responsive and not responsive. And when we can visually see and read what's happening in the corpus as a whole, it makes it a lot easier just to understand all the data at once and start making some decisions. Maybe Georgia is just not a responsive idea here, and we can cut that out. Or that's what it's all about, and we can start diving into that concept cluster to see what else might be falling out of there. So we can get to a granular level. And these are all organized, by the substance of the document. So that goes a long way to helping us understand what's in there and more intelligently start assigning our resources to review these documents. It's much more effective than just starting with custodian 1 or starting at the earliest email.
I notice in this wheel that some of the concepts are phrases as opposed to individual words, and this is something that to me is a little bit new, to actually have the concept clusters broken down by phrase rather than words. How does that help you find what you're looking for?
Yeah, that's really great in the way the index is built. It does use phrases. So something like Sunday's game, and Sunday alone or game alone might give us an idea, but as a concept, we probably know that's a football game, just because of the connections we can make. As a single word, important concepts would be, or important words would be broken apart, and a search term, just a keyword, is going to have a lot of false positives. We may not think about it in a way that is more encapsulated by a 2 or 3 word phrase.
Right. Now, if I click into one of these clusters, I'm assuming I can get down to a greater level of granularity?
You can get down to the single document, yeah.
So this would be a click into phrases in one part of the wheel. And if you click into that, you could get down into groups of documents or individual documents, and I'm assuming you could tag them responsive, or you could bulk tag them responsive or not responsive?
Oh, for certain. And it all stays color-coded, so it's easy to see and keep in mind what the related ideas are, where you go from game latest. You can see what other ideas, what other concepts are subsumed in that single idea. And then the idea of something like extra ticket, you can follow it backwards and understand that it's, an extra ticket for the latest game, and that might be what we're looking for. And so early on, we might be able to find the substantively important documents, and that's really helpful as we move forward in training the machine and trying to find more documents like that that are important for understanding our case, but not necessarily,
Right. So some of the modes are custodians, keywords, date ranges, concept clusters. What are we looking at here now?
Yeah, this is another way to understand the corpus as a whole. These are the people and how they communicate to each other. This isn't atypical. This is a cluster that I would see in normal data sets. It gives us an idea of who the main players are. A lot of times it's because we collected from them that they stand out. And the visual aspect of this, where Pete over there on the left, he's bigger and brighter because he's got more information, more things happening with him. And we can keep clicking here to see more granularly who's talking to who and these lines aren't just a line to connect them. They are the documents, the number, the searches that actually exist. So here on this one, you can see Sarah has a lot of direct communication with Mary Cook. And that red line, it's representative. It's a little bigger on Mary's side, so she sends more to Sarah than Sarah sends to Mary. We understand that. And on any one of these lines, we can click it, and that's a search, and we can start looking at those documents.
So you can click into the documents from this search.
Yeah.
Now, Kaylin, you're managing review teams, and I'm assuming that you don't have review teams necessarily in the Brainspace interface. How does this machine learning, how does this CMML workflow work with your normal everyday review tools?
So and Brainspace version 6 actually has a lot of integration with other review tools, especially with relativity. And that's the primary product with which we use review teams to work with Brainspace. And there's a lot more direct integration in it, which I love because it keeps things moving a lot faster. So when we use review teams, a lot of the things we've seen are great when you have one or two people. You can dig right in, pinpoint those things that you're really looking for, tag them as responsive, and start to train the machine on that. And then a review team can handle something that's bigger. So when you start thinking about predictive coding, you're going to go in, you're going to find these few documents, and you're going to say, this kind of stuff right here, this is what I'm absolutely looking for. And then the machine's going to analyze the rest of the documents and spit out some stuff kind of early. It's going to let some cream rise to the top. And you can have the team start there and say, okay, these are the documents most likely to be responsive. Let's have a review team go in and take a look at them. You're not asking a single partner or a few high-level associates to go in and sit down with documents and train rounds of seed sets like you would with the original TAR 1.0 that we all kind of started with. You can actually have a team dynamically go in, do these things. We feed it back into Brainspace on a regular basis, usually nightly, and it takes the information that the team has given it about what it's coded responsive and what it's coded non-responsive to learn some more. And we do this over and over until we end up with the product at the end. But then you don't have to have somebody whose time is precious and valuable and spare time is very small trying to sit down with these things before you can use a predictive coding model. You can actually use a review team to go in and do a lot of the broader work, while somebody who has that precious time can go in and really pinpoint what they need to, and all of it that then gets used for training the machine.
Right. So, Kaylin, I've got two questions for you. In the ideal world, you would be able to load up your corpus at the beginning, and you would be able to work through this all the way through to the end. And then for the documents that are ranked responsive, do your second pass review and mark it up for confidentiality and privilege, and do your redactions and get it all out the door. And here are the two questions. If you're using this CMML workflow, can you do rolling productions, number one? And the other question is, can you bring in new data even while you're doing this process? Do you have to start all over, or how does it work if you bring in new data?
So the answer to these questions is yes, you can absolutely do rolling productions. And when you bring in new data, this is the best part, you don't have to retrain everything. You can use the information that's already been given and analyze this new data according to the coding that's already been done. You don't have to do new seed sets. You don't have to do new control sets. You don't have to start all over, basically. So instead of a rolling production, we could split the team up. We could have a group continuing with this initial first pass, doing the brain training, and then a group doing your second pass review, which would handle any confidentiality issues, privilege review, review for PHI, or anything else that would need to be segregated from your production set. And so a different group of the review team would handle things, preparing documents for that production set, which could then go out, while the team continues to work through the documents that the machine says are likely to be responsive. So that can continue on in the background as you push documents out the door through a second pass review. If new data comes in, say you get a new custodian, new data comes in, well then you can run the existing machine learning across that new data set, and it will include those documents pushed out to the team for a review saying, we think these are the ones more likely to be responsive. The other part of that is if your new corpus of data contains some new information. We've all seen the thing where maybe most of our custodians initially are from sales. And so we have the terms that sales uses, we have the ideas that sales uses. Those are all, tagged appropriately, some responsive, some not. And we get a new set of data from, let's say, the technology side. And these guys are using new terms, different ideas, they're talking about things in a different way, and the team comes in and says, oh, well, okay, like this is new data, but this is responsive. Now that we understand what they're doing, this is responsive stuff. Well, we can go in and tag it, and the machine learns from that and continues to say, okay, now this stuff is also responsive that we're seeing new here, so these documents you need to take a look at because the brain thinks these are responsive too. And so it's adaptable. When you get new information, you discover new things. Maybe we find a new term of art that the team that that is a responsive term now. We can update it. We can tag it as responsive. We can go back and change documents if we need to, and the machine learns on all of it.
Right. So you can have part of your team actually working on coding and training the machine and updating that training every day or every night, while you've got another part of your team actually touching up those documents marked responsive to get them out the door.
Yes.
So a question came in, and folks out there in the webinar audience, keep those questions coming. We'll try to answer them as they come up if it's in context, but we're going to also try to get to them at the end. One of the questions came up about, are we going to show the relativity integration? And unfortunately not. We're not doing that live today. But my understanding, Kaylin, is that if you've got the relativity integration, that the flipping over to Brainspace comes up as a tab in relativity. Is that right?
So what happens is the tagging is coordinated. So you create your appropriate coding tags in relativity, and those are synced with the tags in Brainspace that Brainspace then uses to say, okay, these documents are responsive, these are not. So it's the tags themselves in relativity coordinate with the tags in Brainspace, and that's how it happens. Is there's that coordination. So it's not a separate tab. You're actually reviewing the documents. They look just like they usually do in relativity. And when you set it up, your coding panel, the tags you actually use in your coding work with Brainspace, and they're coordinated that way.
Thanks. So Dave, back over to you. While we're doing, how do we know when we're done? It sounds like you can get closer and closer, but is there a meter to watch? How do you know when you're getting closer to done finding the responsive documents in the collection?
Well, so we always like to stress that at the end of the day, that's a review management, a kind of process management decision. It's not a purely machine learning decision. That said, there's clearly a machine learning and statistical aspect to that, and we provide a number of tools to do that. So you've got the CMML progress graph up, where you could essentially we will track the progress of how many on-topic documents you found versus all the documents that you've tagged for that topic. And I'll mention, by the way, since I haven't already, that you can have as many topics as you want simultaneously in CMML, be tagging for as many topics as you want, training predictive models for as many topics as you want. But certainly when you've been using a lot of analytics tools, tagging documents, and that graph begins to level off, it's been a long time since you've seen new documents that are on topic. That's one piece of suggestive evidence. Another piece of suggestive evidence is we display the distribution of scores that the documents are given by the predictive model, and there's a graph of that, and you can look at how that evolves over time, and that asks, as you're reducing the set of population, you begin to see few or no documents that have high scores. And of course, the interface makes it very easy to kind of look at the top scoring documents and kind of exhaust those.
Right, so I'm going to go. I'd like to go back to the previous screen here, if I can, Dave. And we're looking at the progress of machine learning. What's represented by these, by the X and Y axes here, and the direction of the curve? What is this telling us about the progress of the machine learning?
Right. So I think the important thing to stress, and this is part of the rethinking that we've done here, is this is showing the progress of finding responsive documents, finding on-topic documents. And they may have been documents that have been found by machine learning, or they may be documents that you found using other analytics tools, or maybe you took the top-ranked documents from the predictive model and you visualize them on the wheel or with communication analysis. So I think part of the kind of fundamental rethinking here is what we're showing here along the bottom is the total number of documents that you've coded for this topic versus on the vertical axis the total number of responsive or on topic or positive or whatever you want to call it. But it's a measure of the overall process of which machine learning is just one part.
So as this graph increases and it moves off to the right, you're going to be looking to see it leveling out rather than spiking vertically. Is that?
That's right. What you'd expect is that as you've found all the easy ones and then you found the harder ones and then even harder ones, that you're getting, you might go, stretch that off along the bottom axis. You might code 100 documents and find only 2 responsive ones, and then the next 100 you're finding only 1 responsive one. And at some point, there's a workflow management, a sort of review management or investigation management decision of whether the additional effort, given that you've kind of exploited all the domain knowledge that you have, exploited the various analytics tools, whether the additional effort is worthwhile. Then this is back to the distribution of scores, which you expect to see that spike at the left then go down as you're exhausting all the on-topic documents.
So when we talk about distribution of scores, what actually is represented here in the horizontal and the vertical axes?
So this is showing you from the left to the right the score of the highest scoring document and then the score of the next highest scoring document and so on. And so what you're seeing here is there's a few documents that have very high scores. Then there's a long plateau of documents that have sort of lower scores, and then there's a bunch of documents which are getting a score of 0 at this point. And you'd expect to see that evolve over time so that you've got and there's an option here which is not shown whether you're going to display the documents that you've already tagged or not. And if you turn off the display of the documents you already tagged, eventually you're going to be seeing no high scoring documents at the left there.
Okay. Now, Charles, I know that you're straddling the worlds between the review team, the technical team, and the legal team. So what sorts of decisions does the legal team need to make along the way while they're doing the coding and they're looking at these scores? What sorts of things do they need to keep their eye on as they move forward?
Yeah, we need to keep our eye on what the end goal, what the delivery is, so that we can focus on the stability of the machine learning, making evaluations about whether putting more effort into training the machine is worthwhile. And in this workflow, what we do is we review all the responsive documents, with the idea of saving time and energy by not reviewing the non-responsive documents. So on the legal end, we need to get to a point where we can comfortably stop review because the rest will be non-responsive, and have good reasons for that, and some of the tech side of this, understanding why that is, why we're comfortable at that point making this decision to stop. Or, a lot of times these tools are incredibly useful because we want to balance our resources, and we can see how the machine learning is progressing and can see if we're meeting our milestones, what kind of adjustments we might need to make, and project out to the future what this is going to continue to take, see if we're still in line, and set expectations, with the court, with opposing counsel, whatnot. But we don't have to wait to the end. We can see what's coming and make some judgments about how to get there.
So let's talk a little bit about money, okay? Let's talk a little bit about, what we're actually saving here. How does it pay for itself? Can you get done faster? Do you want to talk about some actual cases here?
Yeah. Using CMML and the relevance feedback model, where we're focused on spending our time and money on reviewing responsive documents, the documents we're obligated to turn over to the other side, and avoid putting that money into spending a lot of time on non-responsive documents. We had a construction litigation where the review population was just under 83,500 documents. We did some intelligent kind of searching of the documents using the analytic tools to begin understanding the documents, coded and started the iterative process of training the machine. So we reviewed 29,000 and some documents to find and review all of the nearly 6,600 responsive documents. So we avoided looking at 50-some thousand documents. Cut the actual review down by quite substantially.
And how about the case refresh?
This is where Brainspace has a pretty technical advantage in that we can add documents to a model that we've already been training. A lot of times you can't do that, but with Brainspace we're able to seamlessly add in new documents. And this happens a lot where we're early in the case, we need to do a production, we don't have all the custodians, we don't have all the data, but we need to get working on this. So we can start review. This was just 2,500 documents were produced early. We added 11,000 documents, and instead of starting over, we could just use the 2,500 records that we know are responsive, that we've already produced, and use those to train the machine, to start getting the rankings and understanding where the documents are going. We reviewed another 2,468 documents, and so we found the other 1,356 documents that we had to produce next, and avoided, again, looking at 9,000 non-responsive documents that don't have anything to do with our case. We're not obligated to do anything else with. So that was
the third column over there. It looks like this is a big payoff over here, starting with 4 million records. How does that work with a single reviewer?
Yeah, the single reviewer. This is a large corpus. We needed to look through all the documents to find out, what we needed to produce. As the litigation was moving forward and arguments over how and what we're producing were ongoing, but deadlines weren't going to change. So our single reviewer had the protocol, reviewed for responsiveness. We started with a seed set to try to get this going a little bit. It was a very narrow responsive definition that we reviewed. This took a couple of weeks. The reviewer only had half a day every day to do this, but she made it through the nearly 12,000 documents. And out of these 4 million records, we were able to, she read and coded and checked for privilege, confidentiality, et cetera, the 5,413 that we're ready to go with an initial production, and then the other 850,000 out of the original 4 million were likely to be responsive.
Thanks. Kaylin, while we're looking at this chart here in terms of money savings, percentage saved, you know, I know you have worked on linear reviews, you have worked on reviews of keyword search hits, and you've worked with other methods of technology-assisted review, like predictive coding. And a lot of what you're involved in is keeping track of the money because you're managing the reviews, which is obviously the most expensive part of discovery. You know, how do you explain to clients about the extra effort or the less extra effort in using CMML compared to some of these other modes and some of the outcomes that you've looked at?
So the cost is basically that because that learning is dynamic and it happens and things continually get updated, and you can keep an eye on, you know, sort of what your return is. If we have a team reviewing 5,000 documents a day, well, at the end of every day, you can see what's been tagged responsive. If you're only finding, you know, 5 or 6 documents, you may want to say, okay, like that's my cost investment is done. So you can kind of keep an eye on things as they go along. Certainly in linear review, you're reviewing a much smaller population of documents in CMML than you are in linear, which will always save you money. If you have fewer documents to review, then you have less review time, which equals less money, always and forever. Compared to the predictive coding models, I find the dynamic learning happens faster. So especially when we have something like QC feedback with the firm that we're working with or with an end client. So we do a lot of QC on the team's work to make sure that what we put in each night is as accurate as it can be. And then we get feedback from the firm, sometimes with the end client, on new terms they found or discussions that may have been had with opposing counsel where something was decided to be responsive that previously we thought it wasn't. Things like this. It happens all the time. It comes up. But with the dynamic nature of CMML, we can go back and update the coding on documents and put them back into the machine and, you know, reanalyze the corpus of data quite quickly without having to go put in a new seed set. So the kind of dynamic nature of it means that things can be adapted really quickly. And when things can be adapted really quickly, you know that what the team is working on is the most accurate, is the best thing, and you're not wasting any time. You're not having to go back and re-review anything that you shouldn't, or that, you know, any time the team spent reviewing something is wasted. There's no days waiting on someone else to review a seed set to update an algorithm. It all happens pretty quickly on the back end. So you're not having anybody spend time working on something that isn't getting you directly and quickly to that end goal of completing the review. So that's why I see the cost go down, is because every document clicked, every hour spent by anyone is directly getting you to that end goal of being complete with review. And it happens in a much more direct manner. So that keeps costs down.
So Dave, we've had a question come up, actually a few questions come up, but a question come up about how does this differ from, say, the technology behind Brainspace discovery? How does it differ from, say, the technology behind a support vector machine?
Well, so we use logistic regression. Some other vendors use support vector machines. Those are both very good classification algorithms. We prefer logistic regression underneath because it has the additional benefit of providing a better ranking of documents, particularly at the top of the ranking, and producing a output on a probability scale so you can interpret the scores as probability of responsiveness. And
what do you need to feed Brainspace discovery? You just need to load the full text of documents. Is that correct?
That's right, and just to clarify, we've dropped the discovery name, so Brainspace 6 is just Brainspace 6 now.
Okay.
But right, you can ingest from a variety of ingestion tools essentially the text of the documents that's been extracted in various fashions, DAT file, however you want to bring it in. We obviously have connectors to review platforms as well.
So the same volume of extracted text or OCR text that you might use in Relativity, you can use that same library of text files for ingesting into Brainspace.
Well, yeah, and you can of course bring it directly across from Relativity. We've got kind of a high-speed connection there that'll just bring the data right across.
So looking at this percentage saved over here on the right-hand column, this must be very gratifying to you when we're talking about zero extra effort.
Well, right. So, our whole goal is that, in the perfect system would be one where you never looked at anything except a responsive document. Obviously, in the world of ambiguity of human language and whatnot, that's never going to be the case. But, this is very gratifying, the more we can see in terms of people are spending their time looking at the documents that actually make a difference to the investigation or the litigation or whatever the kind of analysis project is, the more we can focus in, the more we can have people spending time looking at the stuff that actually makes a difference, the more money they save and the more efficiently the whole world operates.
So I'm going to ask you to focus now on a different column on this, the documents reviewed column. And I'm going to sit in the place of the litigation, the requesting party, the person who's expecting discovery to be produced to me out of this. And I'm saying here, geez, Dave, you've only reviewed 8,739 documents out of 338,000. Or you've only reviewed 3,548 out of 142,248. How do I know this is any good? How do I know that you have found reasonably all of the responsive documents? It gives rise to those questions about the defensibility of a TAR protocol that when we're negotiating with opposing counsel that come up in every case. I know that in recent years there have been fights about what's the richness of the collection, and let's have a fight about the precision and recall and what's the read rate, and how deep into the collection are you going to actually read, and we want to have a fight about those in advance. What's the argument for doing it differently, and what should we actually be thinking about when we're talking about defensibility and negotiating a TAR protocol?
Well, I'll say at first that I'm not an attorney, and at the end of the day, defensibility is a legal concept.
But
okay.
I got two attorneys coming up right behind you on this topic, so you can take it from the technical part.
So I'll say what I can say as a computer scientist. With respect to the kind of effectiveness metrics, the CMML process has a sampling capability. You can draw a sample from the documents that haven't been reviewed, get an estimate of the fraction of the unreviewed material that's on topic. That can sometimes be valuable in some contexts that can be appropriate, useful for a negotiation. But I think it's important to think about this not just as a statistics exercise. The first thing to say is it's kind of, it's unambiguous that modern text analytics technology is going to do a much better job of finding the documents that are responsive, that are on topic, whatever the topic you're defined is, than kind of older keyword search. And so it's going to be very hard for an adversary to argue that you shouldn't be using those tools. So then the real question, often then boils down to when do you stop using these good tools? You're using these good tools, when do you stop using them? And the validation set I mentioned is one piece. The kind of the displays that I discussed under stopping, you look at to decide when you've kind of exhausted your possibilities, the leveling off of the curve, the distribution of scores. those all factor in to an argument. And essentially it comes down to, when is the cost of finding additional responsive documents when you've used all your knowledge of the case. Maybe your adversaries gave you ideas too. They usually have something to say. And you've leveraged all that knowledge using the analytics tools. You've leveraged all the documents you found using machine learning. You've used the predictive model to prioritize the most likely responsive material, and you're just not finding much new at that point. And then maybe you've done some statistical sampling to get you an estimate of what might or might not be out there. Those are all the kinds of statistical machine learning things that contribute to what in the end is a legal argument about legal concepts like proportionality and whatnot in a litigation setting. Obviously, in an investigation setting, it's very different. Sometimes the investigation's over when you find a particular smoking gun document. It's, there's nobody sort of saying, well, you should keep using machine learning. I mean, we got the guy. It's over. And so it's important to recognize that litigation is not the only context here.
Thanks. So, Charles, I know that you've been involved in discussing, negotiating ESI protocols for the use of CMML and this workflow in particular. What are the kinds of questions that come up? What are you seeing as the pathway to resolving some of the disputes about the use of TAR?
Yeah, and a lot of it has to do with, in the EDRM, I generally get involved with our clients from the beginning. And it's a lot cheaper to over-collect rather than under-collect and get more, and then we go through that process of finally reviewing documents, and where, we start with 1 million documents, that may be just because we were meeting an initial obligation of preserving, and we decided to move and promote data. So understanding where the data came from and why we have it, and controlling costs to get to, producing what we're obligated to and the other side has a right to, is understanding the whole picture. And so what needs to be reviewed, the big argument now is, how are you going to identify that population? Meaning, are you going to apply keywords and cull a large chunk of the population just based on that? Or will you use a model like this, where you just train on the most responsive, and there's costs involved on both sides, and the proportionality is always a question. So controlling those costs aren't just a benefit for my client, but to come back and say, well, that's way too expensive, we've got a defensible reason for saying so at that point. But those are all considerations, yeah.
Kaylin, if you're involved in a review using Brainspace 6.0, and you're doing a review and a touch-up of responsive documents before producing them, are you also doing validation sampling, statistical sampling of portions of the collection that came up as not responsive?
We certainly can, and I have worked on reviews where we absolutely have for our own purposes, and I've worked on reviews where we have because opposing counsel asked for it. They wanted to make sure that they knew what they were getting out of these productions was everything that they were supposed to get. So we produced validation samples for them. It was a random sampling of documents from the set that was not ranked high enough to be considered responsive and reviewed by the team. So we've done them for our own purposes to make sure that we are looking at things, we are looking at everything. We've done them as random samples. We've done them as targeted areas, so that cluster wheel back from the very beginning, that if everybody was thinking about it, we can sample and say, we can look at things and say, okay, well, we've looked at a lot of documents from these terms over here on the right, but there's this area of the wheel over here on the left that we haven't seen anything from. let's go make sure. And so we can pull a set of documents from that and go run a validation set on that for half a day. I can stick, 2 people on it and say, tell me what you find in here. And that can all go into things. So there's a lot of ways we can use the team to kind of look around and make sure that we've gotten everything we need to get, and that we aren't missing any terms or anything else that could be out there that could be responsive. So we've done it, and we like to do it just to make sure we're doing a thorough job and a good job with it, because that is, again, as one of the 2 attorneys here, that is how we make it defensible. That is how we say to ourselves, to the judge, to opposing counsel, to whomever, this really is a process that found everything that needed to be found.
So let me ask you really specifically now, because we've seen the language in the case law, we've seen the language in ESI protocols, we've seen it in, for example, Sedona conference materials about statistical sampling and validation sampling, and sharing that information with the requesting party. For those projects for which you've done that validation sampling, what actually are you sharing?
So we are sharing in this particular case, it was a set of 500 documents that the machine ranked below the value we were using as responsive, which was actually 0.3. So the machine said,
did you share the actual documents, or did you share the review outcomes?
We shared the documents themselves. We actually turned it over as though it were a production at the end of a review, the same way we would have given them a production of responsive documents under the ESI protocol. We said, here's a set of 500 in exactly the same format. You take a look at them, and you get to see these in the same way.
Right. Now, we know most courts aren't going to require the production of non-responsive documents. In those kinds of settings where the parties are obviously adverse and they're reluctant to do that, you're still able to show any responsive documents that come out of that sample of 500 and explain why they're there. Is that fair?
Yes. Yes. So
and then you can feed that information then back into the machine to find out if there's any more like those.
Yes, we can, and that's exactly what we would do. If they came back and said, we think these are responsive for this reason, we can say, okay, well, we'll go back and we'll do, we'll take that input, we'll do another set and see what else this puts out. So that can be done as well to, if the parties are truly adverse and they really aren't comfortable with it, we can do that at some point there does become a cost balancing effort of, you're asking us for this, but the cost of it is extraordinary. But at the same time, to get everyone to that comfort level, yeah, we can go back and add to the machine learning the same way we normally would.
So Dave, back over to you for a minute. So when we're talking about sampling, obviously in these return on investment charts, we've showed a lot of savings, and we've seen a lot of trumpeting about, the cost of sampling and statistical validation and so on and so forth. It's you're making us review more than we have to review. What sort of numbers, if you're talking about 1 million documents with, say, even 20% responsive, or 1 million documents with 10 or 5% responsive, how many documents are we really talking about in rough numbers in terms of having to do a validation QC based on a statistical sample?
Well, it depends on what you're trying to do. If you're trying to estimate with a certain margin of error the proportion of responsive documents that are in the null set, that are in the documents that are not that have not been reviewed, and you want a particular margin of error plus or minus 5%, 2%, whatever, I'd have to actually look up the number, but I mean, a sort of standard number is something like 2,400 documents, and the null set would give you, I think I shouldn't be doing this off the top of my head, but I think that's a it's either 2 or 2.5% margin of error at a 95% confidence level, and that's independent of the richness of the collection. If you're trying to estimate recall, that's a very different story, because the sample size you need to estimate recall depends on the richness of the collection, and we won't get into the details of that. But that then becomes a very different story, and that's probably the biggest source of conflict that there's been around statistical sampling.
So that it's sort of leading me to think that we shouldn't have those fights about precision and recall and the extent to which we're going to review. We shouldn't be having those fights in advance of actually reviewing. Is that fair?
Well, you certainly should not be. I mean, this is what I would advise anyone. No one should commit to particular statistical targets for estimating recall without having taken a sample that tells you what the richness of the collection is. That I think, if I had to give a single piece of advice to anyone about predictive coding, that would be way toward the top of the list. But it's an entirely additional and important question. What are even the circumstances in which it's appropriate to be estimating recall? And that's a subtle question that has both legal and technical aspects to it. I think in general, I would say, don't get into discussions about statistical and machine learning issues until you understand your data set. That is an unambiguous piece of advice that I can give.
There's a question that came up about the influence of metadata in the machine learning. Is metadata used in Brainspace as part of the information on which the ranking is performed?
So we're not currently doing that as a sort of standard part of the workflow. If somebody wants to put the metadata fields into a text field, I mean, we have the option to point to which fields of the data get treated as text. If you want to use metadata as text, you can do that. We don't, by default, create separate features from metadata, though that's something that we've considered and look at from time to time.
Thanks. And for Charles, sometimes when you're in the middle of a project, you've got opposing parties that want to give you key terms to put in there to focus the training. Do you sense that there's any particular integrity concerns with them in terms of the training model, or do you think that's fairly training neutral?
It can be training helpful. I mean, if I know what opposing is really wanting to get at, that can save us some time and money. What the results of those search terms might be, that's another story that I would talk with my client. We might need to do some strategizing, but I don't mind the other side showing me their hand.
Thank you. Any other questions from the group? Anything that stands out right now that you want to put into your question box right now, and we will see if we can stump the panel. Dave, any closing remark, words of wisdom?
I think we're super excited about CMML. We think it's a very different perspective on how to use machine learning. What we're hoping is it take the fear away from using machine learning, that it can just be just another analytics tool that people use to get their job done. Not this kind of sort of large, gigantic expense, worry, conflict, and whatnot. And I think that's where the field is going. It's going to, in a few years, I think there's going to be much less controversy. It'll be just another tool that gets used.
Thank you very much. If there's any questions that come up, please write us at blog@d4discovery.com or marketing@d4discovery.com, and we will get back out to you. I want to thank the panel, Kaylin, Charles, Dave. Thank you very much for your time and your participation in putting this together today, and thank you for the folks out there for spending this hour with us.